And so there's a reason, by the way, that I do this in logs, which is this. So the actual measure I have is like, missing is equal to log reported minus log alpha times actual, where alpha is that kind of like loss ratio to tear the scale. Right? So the reason I do this in logs is I can rewrite this as log reported minus log actual minus log alpha. Right? And so why is that useful to be able to rewrite it that way? Well, I'm going to run a regression where I'm going to put this on the left-hand side. I'm going to say, well, gee, does an experiment move this ratio up or down? Because the alpha term kind of is just an additive constant, that's going to be picked up by the constant term. So that says, look, I did my best to sort of tear that scale at 0. But if I got a little bit off, my overall estimate of how much is missing is going to be wrong. But it's not actually going to affect my estimate for how the missing amounts change from one village to another. So that's like another kind of nice reason to use logs. OK, questions? OK. So what were the audits? They were conducted by the regular government audit agencies, the regular government auditors. And what were the penalties? Well, the penalties were they basically had a big meeting and they said, here's what we found in your road project. And fix these problems. And if they actually find some true malfeasance, they might make you there's some small probability of criminal action, but that's pretty rare. And then I told you the timing or whatever, to how we made it real. OK, so any questions about the setup? OK, so here are the results. So again, these are CDFs, right? So the solid line is the treatment group, and the dashed line is the control group. And so what do you see from the CDF? How do you interpret the CDF? And what I'm plotting here is the CDF of this log reported minus log actual.
Can we shift it to the right so the mean is increased?
For which?
For the I guess the control.
Right. So the control is clearly shifted. So this I think first order stochastic dominates this one. This one first order stochastic dominates that one. Sorry. It's uniformly shifted. It's clearly shifted to the right. So what does that mean?
So that means that you're. So sorry. Is the
audit is the dark line, solid line, and control is the dashed line.
The audit line has kind of fewer major items in the road.
Or it has less of this variable. It has less of this log reported line. The major items in road is a technical detail that we don't need to talk about. It's just log reported minus log actual. Okay, so less is missing in the treatment group compared to the control group. Is that clear? Now, another thing that's kind of interesting, which I did not know until I started this. I mean, I didn't know any of this until I started this. This is just plotting the PDF, which is sometimes easier to read than the CDF. And what's kind of amazing here is, there's a huge amount of mass pretty far away from 0. So it looks pretty normally distributed, right? But how do you interpret this? If this variable is equal to 1, how do you interpret this? These are natural logs.
I mean, it's about like twice as much. No, I'm sorry.
OK, so if missing is equal to 1, right? That implies that log reported minus log actual is equal to 1, right? So that means that log reported equals log actual plus 1, right? What's 1? 1 is log of E, right? So that means that this is equal to log of E times actual. Right? So the reported amount is 2.7 times as high as the actual amount. Right? That's just to interpret magnitudes. So that means that a substantial amount of people are like close to 1. Not a lot of close to 1, but they're pretty high. Certainly a bunch, if this is sort of 50, double, right? If this is sort of saying the reported amount is double the actual amount, that's here, about log 0.69. And there's a substantial amount of people that are to the left, where actually actual is greater than reported. So what do we make of, what do we make of that?
Maybe they're just bad at accounting.
Yeah, that's one option. This is, I think, an even better option. Maybe they're bad at accounting, or what's another option? I'll give you a hint. Maybe these guys aren't so great. Right? As I said, this is not rocket science. There's lots of measurement error here. Right? So it could be that there's a substantial amount of measurement error. Now, measurement error isn't a problem. Right? It just means that it doesn't mean that our estimate is wrong. It just means we have big standard errors. So that's fine. Right? But one reason that this is important is you might say, well, gee, how come you, the researcher, can figure out how much corruption there is, and those auditors can't go do what you're doing? Right? And I think a reason for that is measurement error. Right? Averaging over 600 roads, I can get a pretty good estimate of the mean in one group and the mean in another group. But that's not what an auditor cares about. An auditor sort of wants to care about saying, look, this road, did you guys steal or not? Right? And so if there's measurement error in these techniques, they can be good for research, but that doesn't mean that you can be good for actually doing, putting people in jail or whatever.